So your first one, your work is perfect, so we'll just walk through that. It says Clifford desires an accumulated amount of $25,000 after 10 years invested in an account with 4% interest compounded quarterly. How much does he need to invest now to meet his goal? So you have the formula that the present value that he needs to invest now will equal the final amount that he wants to achieve over 1 plus the rate over n, which is the number of times you compound it per year, to the nt. So you just plugged and chugged into this formula. The present amount will equal the final amount that he wants to achieve over 1 plus the rate, which was 4%. Always scoot that decimal 2 spots over to make it a decimal, divided by 4 because we're compounding quarterly, so we're compounding 4 times a year, to the n, so another 4 times t because he wants to do it in 10 years. So you plugged in this on your calculator, 0.04 divided by 4 gave you 0.01, and then 1 plus 0.01 gave you 1.01 to the 40th power. So you plugged in 1.01 to the 40th and got that nasty number there. Took your calculator, did that, divided by that, it gave you that, rounded to 2 decimal spots. So here we want the effective annual yield for blah, 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 blah. And I think we had one problem like this. So what you're going to do for effective annual yield, sometimes they call it annual percentage yield, or APY. You're just going to use your regular compound interest formula, this guy here, and you're going to pretend you start off with $1 and that you're going to invest it for 1 year. So plugging and chugging into here, we're going to pretend we start off with $1 and we have 1 plus our rate in this case was 3.6%, so we just scooted the decimal over twice to get 0.036. We're compounding daily, so 365 times a year. So 365, and we're just going to pretend we're compound for 1 year. So at the end, we're going to plug this number in on your calculator, and what my calculator gave me when I did this number here was 9.863 e to the negative 5th, or your calculator might say times 10 to the negative 5th, which means you're going to take that decimal and scoot it over 5 places to the left. So take that decimal and scoot it over 1, 2, 3, 4, 5 spots to the left. 1 spot went to clear the 9, and there's going to be 4 zeros in there. So now I have 1 plus 0.4 zeros and 9863, and I could skip writing that and just add the 1 right away. 1 point blah blah blah. Take this and raise it to the 365 power and I get this, and of course if I times it by 1 it didn't change it, so I still get that. So that's how much money you would earn if you put in $1 for 1 year. So the annual percent yield, you're just going to take that amount minus 1. So take that amount minus 1, basically just chopping off the 1 that you got in the front. So that's like 3.67% annual percentage yield, or effective annual yield. So that's how those guys are done. Excellent. And for this guy, your work was perfect. You saw the keyword sinking fund, and you wrote your sinking fund formula over here, and you just plugged and chugged into that. So you saw that the final amount that she would like to have was $20,000. So $20,000 there. The rate was 5%, so you wrote it as a decimal 0.05. She wants to invest monthly, so that's 12 times a year, so n is 12. So then you've got 1 plus 0.05 divided by 12. The n was still 12. The t, she wants 4 years, and then minus 1. And so you just plugged and chugged this in piece by piece. You did this one first, 0.05 divided by 12 gave you that. And this, you did 0.05 divided by 12, gave you that, and you added the 1, took that to the 48th power, and hopefully you remembered to subtract the 1. And so if you do 20,000 times that, you get that. I'm just going to check this number here. If I do 1.004, 1.004 1666667 raised to the 48th power, you get that, and then you saw that you were supposed to subtract 1, so you just cut off the 1 there to give you that 0.22 blah blah. And so then you did that divided by that on your calculator to get that. Excellent. So here you saw your keyword ordinary annuity. So you wrote out your formula for an ordinary annuity. And we'll try to see, it looks like you took off a point. I don't think you would take off a point just for leaving off that bracket, so let's see if something went wrong. But that looks fine. You plugged in the initial investment was 200, you have 1 plus, the rate was 8%, you're compounding monthly, N was 12, 20 years, minus 1. And so then you're going to do, so if I plug in 0.08 divided by 12, 0.08, get rid of that, 0.08 divided by 12, I get that, and I did 1 plus that, so you've got 1 plus that, and you need that to the 12 times 20 power, so I'm going to add plus 1, and I need that to the 12 times 20 power. So 12 times 20, 12 times 20 is 240. So I need 1.00666666666 raised to the 240th power, which gives me 4.92. Which I don't see there. And then you would take that and subtract 1 from it. So, oh wait, nope, I see it. So you subtracted, there it is. So you took the 3, you subtracted 1, and you got that. I think you might have just forgotten that it was all supposed to be times 200. So you did all this part here, did all that part there, but I think you just lost that 200. So let's put in a 200 here, times 200, and see what we get then. So I'm going to subtract the 1 to get the 3.999. I'm going to multiply by 200 to get 785.36. So that's going to be, sorry, so 785.360554 divided by, and that bottom should still be okay, 0.00666667. So I'm going to take that guy divided by 0.0066666666, blah, 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 and I get 11, that guy there, and that should be your final. So 11,780,408. Does that make sense?